All right, one final video that goes through more examples on the double angle and half angle formulas. So first of all, we see something like this. So determine the exact value of cosine of 2 arc sine of 4/5. Okay, so to me, when I see this, right, I remember that arc sine, right, that whole thing, that's an angle. That's theta. So this is just like saying, cosine. This is the same as saying equals cosine of 2 theta. And then I know a formula for that. And then I'm just going to say where theta is equal to arc sine of 4/5. Okay. So I can go ahead and say, okay, I know that according to the formula, this is cosine squared of theta minus sine squared of theta. Okay. And then I just need to evaluate, right? That's where I'm a little stuck, right? But I haven't used any information about the angle that I'm given, right? So get a little picture. Sine is restricted to quadrants 1 and 4 when we have an inverse function present. And since the ratio inside is positive, that's going to mean we're in quadrant 1. Okay, so in this quadrant, I could imagine angle theta is there, and then for theta, right, I know the ratio, the opposite to hypotenuse is 3, or is 4/5. That means adjacent side is 3. So then I can come back and say, okay, let's use this diagram to help me evaluate. Cosine squared here would be the ratio 3/5 squared minus 4/5 squared. And so then, let's see, this is, 9/25 minus 16/25. So then I end up with negative 7/25. And that would be my answer. Okay. So really just remember, and this kind of happens every time we see an inverse trig function, that really is just some angle theta. So don't let the inverse trig function scare you. All right. Next example, I think you have enough of the tools to do this one. So I want you to pause the video, take a shot, and resume the video when you're ready to see the solution. And here we go. A lot of work to follow. Where I started was I got a diagram. Okay. So I took all this information, put it in a diagram. Okay. Then I found sine of alpha over 2 first. Or I guess second, to decide the sign, right? That's where I went and said, kind of made the inequality and said, okay, well then, if this range holds for alpha, then divide all parts by 2, and we see that that new range for alpha over 2 is in quadrant 2, and sine is positive there. And then after that, I just kind of cranked through it. I came down and found cosine of 2 alpha next, just kind of substituting the values from the diagram, went through. And then fourth, I found tangent. And I did it the shorter way, in my opinion, sine of alpha over 2 over cosine alpha over 2. I had sine of alpha over 2 from above, and I just had to go and find cosine of alpha over 2. So this is like 4.5. Had to find cosine of alpha over 2 to simplify. Okay. And lastly, with all of this stuff, I get that it seems like it's just a lot of formulas. So why do we care? Okay. These formulas don't pop up frequently, but they do pop up, especially in the field of physics. If and initially in physics, like physics 1, you won't see these too much. Maybe if you work a little bit with circular motion and that sort of thing, you'll pop up because sometimes you break it into components where you talk about sine and cosine of an angle. So maybe there, but generally in like physics 2, or maybe towards the end of physics 2, you'll start talking about light and optics, and in there there is the equation of a plane wave, and so it's kind of restricting the motion of like light or something to a single plane, like a 2D sheet of paper. And you get this equation, sine of kx minus omega t, and this is actually kind of one of your first exposures to a multivariable function, where the output is dependent on x, which is a displacement, and a parameter time. So kind of an interesting formula in an error in of itself. But you can see that inside of sine we have a difference of angles, and sometimes we might assume like there's no, no angular speed. So then we just have kx, in which case then we have, it could be a 2x, and then you have to expand that out. Or if you do have that difference, you have to do angle difference in there. So just kind of one context where you could see this equation pop up should you continue in mathematics a little bit further. Okay, optics to in some cases when you're working just generally with optics and lenses, you can get this happening. That's usually just basic geometry, but you do see some of these formulas pop up there too. So know that all this work is not in vain. We are going to put this to use at some point in our lives. Well, should you continue in physics at least. All right. So that kind of wraps up this section, and we'll get some more practice in class.